So I'm just very briefly discussing a survey that we administered last year on software usage in the planetary sciences, soliciting respondents through PIN and at PDW. I think the major contributors to the design of this survey were Michael I., Angeline Burrell, Trent Hare, Jason Laura, Andrew Annex, Mary John Baranow, Chase Millian, and me. So a non-trivial proportion of those people are, of course, here right now. So they may have additional things to say. But and also, if I've left anyone out who'd like to be credited, contact me and let me know. But very broadly, we learned that a bunch of people are regularly using Python in planetary science. That's about 2/3 of our respondents, and that there's a lot of demand for Python tools. I feel like belaboring these general points in this forum is preaching to the choir. So I'm just going to talk a little bit about the background of this work and directions I think it could go, and also about some aspects of the results I think are especially interesting. This is very informal. I'm not going to use slides or anything. If you'd like to see more of the numbers, please take a look at my summary, which is up on the Million Concepts GitHub. And I also think the link is up on the OP forum. And finally, I should note that we never got to any kind of formal assignment of authorship. So that survey and my interpretation of the results here and generally are my opinions and don't necessarily represent the views of anyone else who worked on this project. Okay, so our work on this started around discussion of the nascent Planetary Pi project last year. I don't remember who kicked off the conversation about this research as such. We just wanted to get some information that would help guide potential development efforts and also make coherent arguments to outside parties about its utility. And we also thought that this kind of information might be useful to developers in the community at large. I'd add that although the survey is Python-centric, we didn't want to look just at Python. And one of the things a broader effort might do is aggressively expand that further, looking at specific packages in other languages as well, broader kinds of software practices, et cetera. The most proximate inspirations for this work were user research done in the heliophysics community. I think Evangeline was primarily responsible for that work, along with some prior work by Andrew Annex, and also a more focused survey in the small bodies community by the SBPy team. And then more broadly, we've noticed that there's kind of a shocking paucity of publicly accessible user research in scientific software, honestly, in scientific practice generally, compared to other fields. Like, if we could look at MathWorks or Wolfram's archives, I'm sure there's a whole lot of excellent user research in there, but we can't. So, okay, so results. What did we learn? Python was the most commonly used language among our survey respondents, and the distribution of the next most commonly languages is somewhat interesting. In order, they are IDL, MATLAB, and Fortran. Now, these are all, assuming people are using at least Fortran 77, which I assume they are, array programming languages. IDL and MATLAB are array first, and I think most users of modern Fortran treat it as close to an array first language. Also, these other three languages are conventionally rendered in all capital letters. So to me, this implies that, at least in planetary, scientific programming is still largely array programming, in direct lines of descent from Fortran, APL, and David Stern's proto-IDL work at last. Also, unsurprisingly, the most commonly used Python libraries among our respondents are array first: NumPy, SciPy, Pandas. Python's ability to play at being MATLAB and IDL, or in other disciplines, SQL and Excel, is no doubt a major part of its popularity here. And so it's important that we, as developers, continue to think hard about the centrality of the array, not just as a formal mathematical structure or category of a data type in any particular implementation, but as a cross-language conceptual category. array-first implementations in general are likely to reduce friction for new users in the sciences. I have one more comment about this, which is beyond the scope of this investigation, but it's also important, I think, to consider ways in which the conceptual centrality of the array might limit the ways in which we think about scientific software, and in which decentering it sometimes might produce fruitful results, even if vectorization of some type continues under the hood. Like, do we tend to lose the power of symbolic manipulation by reducing mathematical objects to numerical operations at too high a level? Just broad thought. Okay, next. Only about a third of the Python using respondents reported regular or constant use of Jupyter Notebook, which went against my intuitions. I tend to assume that most scientific and more broadly data-driven programmers are using Jupyter constantly, and that Jupyter-based documentation will really help drive engagement. That may not be as true as I think. Most of the regular Python users, perhaps unsurprisingly, use Anaconda. We did not distinguish between Miniconda and Anaconda, the big, heavy, broader distribution, however. We found a number of specific patterns of complaints and pain points. One of the big ones is data handling. So some of these were just very general complaints like it's hard to open data up in Python or hard to teach students how to open data up in Python. And some of these things aren't related to actual like objective capabilities of the language, right? Like Baptiste Ciccone pointed out on the Open Planetary Forum the other week that although a couple of respondents complained about CDF, Python actually has unusually great tools for CDF. So some of these comments should be read about discoverability, documentation status, maturity levels of tools. Like the popularity, widespread use, and diverse ecosystem of Python are serious strengths of the language, but they also present challenges. Like, for instance, if I want to use CDF files in IDL, I probably just use Harris's native procedures. But in Python, because those readers aren't integrated into one of the handful of community standard software suites, I have to hunt them down, select and assess them, learn their individual APIs, which differ broadly from one another, etc. So there are a lot of questions we have to consider, not just about tool development, but tool marketing, integration of tools into larger suites, improved documentation, education efforts, etc. And this more specific question of opening data up is really interesting to me in the sense that we probably should prioritize more than we do the production of interfaces that rapidly reveal themselves to users in terms of their core functionality as applied to common use cases. And things like notebook-based documentation are obviously great tools here. Another really common category of complaint that I think we should attend to as developers is a large set of complaints about setting up Python environments in the first place. So maybe education is a solution to this. Maybe more Conda Forge feedstocks are a solution to this. And maybe some of this is a high-level Python distribution or Unix admin problem that we can't solve as in developers. But it's something we should keep in mind about adoption and usability. Okay, so there are a ton of limitations with this survey. It was a relatively small sample. It was self-selected, and in particular, probably self-selected in a way that overrepresents both Python users and people with strong opinions about software generally, including those who strongly dislike Python. I would point out that these problems are not especially different from how problems that happen with qualitative research in product design, UX, and the social sciences. You don't have to get a perfect sampling or run an experiment to usefully identify and describe a family of phenomena, or to build a narrative that helps guide design practice. And it's also the case that 58 people is a much larger proportion of the planetary science community than it is of, say, the population of France. However, this being said, several people pointed out that there are subdisciplinary biases within the survey, specifically towards planetary surfaces, remote sensing, and imaging. Okay, so the work needs to be expanded if it's going to continue or be useful, and there are a variety of directions a project like this could go, and a variety of forms final output could take. Obviously, larger and broader data collection via surveys or similar instruments would be interesting. And of course, the broader array of tools from user research, in situ observation, focus groups, targeted interviews, collecting rich usage narratives, etc. If we do feel that as scientific developers, we need more user data, which I strongly believe that we do. It would be good in all of these efforts to get specialist assistance. So collaborators from experience research, from sociology, qualitative anthro, education research, design studies. We sometimes use these perspectives to look critically at our institutional structures, but very rarely at the nitty-gritty of our workflows. Like, just for instance, if Janet Vertesi's observations about the ways that we anthropomorphize and use embodied cognition about in situ instruments are accurate, what implications do they have for how we might leverage embodied cognition in remote sensing software design? Interfacing with people from disciplines like this could be extremely helpful for answering questions of this kind. And then finally, if these results were to be extended, or if more projects of this kind were to be launched, there are questions about output format and venue. It would, of course, be nice for a variety of reasons, including the appearance of legitimacy, if some portion of output like this took forms that could be published in peer-reviewed journals. Conversely, journal articles are almost certainly not the best vehicle for actually publicizing and distributing the results of research of this type. So that remains an open question as well. And I think everyone who participated in this survey effort would be strongly interested in gathering more collaborators and hearing ideas about how it might be more successfully and extensively extended in the future. Okay, those are my notes in brief. Thank you.